Hi guys, so today we are going to focus on solving linear systems by a method called substitution. So go ahead and title your paper, Solve Linear Systems by Substitution, and we are going to write down the steps that are going to help us be successful in doing this. So the very first step is to solve one of the equations for one of its variables. So sometimes it may be given to you where one of the equations is in y equals mx plus b form, and y has already been solved for, or x equals, 5y minus 7. So those are examples of the equations for solving for one of these variables, or you may have to actually manipulate the equation to solve it. So when possible, you want to solve for a variable that has a coefficient of 1 or negative 1, because that is the easiest to solve for. So then step 2, once we've solved and we have an equation that is equal to one of the variables, then step 2, we need to substitute that expression from step 1 into the other equation and solve for the other variable. So it makes a lot more sense when we do an example. But we're going to take, for instance, if one of the equations is y equals 2x minus 7, we're going to take that expression of 2x minus 7 that's equal to actual y. Y equals that. So we're going to replace our y in our second equation with that 2x minus 7 and solve for our x, because now we only have x's. Like I said, visually it will make sense when we get there. And then step 3, you will find an answer. So it'll be x equals, 5. So then you're going to take that 5 and plug it back into step 1 and solve for what y equals. So like I said, it's very kind of abstract right now, but when we do some examples, it'll make sense. Please make sure you have all these steps in your notes. All right, so let's take a look at example number 1. Example number 1 has two equations. So here's our system, y equals 3x plus 2 and x plus 2y equals 11. So remember, step 1 is to solve either one of the equations for one variable. So if you look, we already have the very first equation. I'll call this equation 1, I'll call this equation 2. So equation 1 is already solved for y. We already have y equals something. So step 1 is really already done because equation 1 was written that way. Step 2 tells us to substitute it into the second equation. So what that means is y is equal to 3x plus 2. That they're equivalent to one another. So in my second equation where I see a y, I can replace my y with a quantity of 3x plus 2. Because if y equals 3x plus 2, where I see y, I can replace that with 3x plus 2. So if I do that, I'm going to rewrite it underneath. I now have x, which is what my second equation begins with, plus 2. And instead of writing y, I'm going to open a set of parentheses and plug in a 3x plus 2. I'm replacing y with the 3x plus 2 because equation 1 tells me that y is 3x plus 2. And that is all equal to 11. So now that we've done that, do you see how we only have x's in our equation? So since we only have x's in our equation, we can solve for x. So let's use those solving equation skills, distributive property. So I have x plus 2 times 3x, which is 6x, and then 2 times a positive 2, which is plus 4, and that all equals 11. I need to gather my like terms, which are x and 6x, which gives me 7x plus 4 is equal to 11. Now I need to solve by subtracting 4 on both sides. So I end up with this cancels, 7x is equal to 7, divide by 7 on both sides, so x is equal to 1. So now I've solved for my variable. So x is 1. Remember, our solution is still a point. So that means that I can fill in the first part of my solution is going to be 1 comma something. Now I have to find that something. What is that y value? Well, I know x is 1. So if you take a look up, here's step 3 from the list. Take a look at equation number 1. It's set up as y equals 3x plus 2. Well, if I know x, can't I plug in 1 for x and find y? The answer should be yes. So over here, I'm going to give myself some space. Y equals 3x plus 2. Instead of my x, I'm now going to rewrite it as y equals 3 times my x value here of 1 plus 2 to figure out what y is. So y is equal to 3 times 1, which is 3, plus 2. And so y is equal to 3 plus 2, which is 5. So my solution up here is 1 comma 5. So that's where my two lines would intersect if I were to graph them. Please make sure that's all in your notes. Let's take a look at example 2. Example 2, take a look at equation 1 and equation 2. Are either of them solved for one variable? Your answer is no. The first one is x minus 2y equals -6, and number 2 is 4x plus 6y equals 4. So looking at those two equations, do you see a variable, it can be x or y, that would be easy to solve for? And hopefully, so this is our step 1, hopefully you're saying, yeah, the equation 1, x has a coefficient of 1. It would be really easy to add 2y on both sides, so I have x equals something, which is awesome. So that's what we're going to do. So in our step 1, I'm going to write it up here, and I'll box it so we know it's step 1. I'm going to take x minus 2y equals -6. I'm going to solve for x. So I need to add 2y, which cancels it on this side, and add 2y. So x now equals 2y minus 6. So now I'm going to use that equation in my step 2. Remember, your step 2 is taking what that variable equals. So 2y minus 6 is equivalent to x. And I'm going to take that and plug it in where I see x in my second equation. So I have 4, and instead of x, I'm going to write 2y minus 6. And then continue my equation, plus 6y equals 4. So now if you notice, I have all y's in my equation. At step 2, you have to have all the same variable. If you don't, something has gone wrong with your substitution. Distribute your 4. So now I have 8y minus 24 plus 6y is equal to 4. So we need to solve. So I need to combine my like terms, positive 6y and an 8y, which gives me 14y minus 24 is equal to 4. Go ahead and add 24 on both sides. So I end up with 28 is equal to 14y. Divide by 14, divide by 14. So y is equal to 2. So once again, I'm going to put my answer up here. Y is 2. So y is 2 in my solution. The third step then says, well, you have to solve for the other variable. I'm going to do that right here. So step 3 says, now you found y, you got to find x. So you have multiple ways you could do this. Well, you know y is 2. And don't you have an equation that you just already worked for and created that says x equals 2 times y minus 6? So use this equation. It's already set up for you. So we're going to use x is equal to 2y minus 6. So x is equal to 2 times my y value, which I just found was 2, minus 6. So x is equal to 4 minus 6. So x is equal to a -2. So back in my answer, we have -2, comma 2. So these are just two different examples. Example 1 where y was already solved for us. That's the easiest of them. And example 2 where we had to actually solve for x to then plug into our second equation. Now you don't always have to solve the first equation. Sometimes the second one is better than the first. It doesn't matter. All right, let's take a look at example 3. So if we look at example 3, I need to, again, evaluate my equations. -5x minus y equals 12 and 3x minus 5 equals 4. So I need to solve for the easiest variable. Once again, it happens to be in equation 1. It could totally be in equation 2. So in equation 1, hopefully you're like, ooh, solve for y, because it has a coefficient of that -1. So step 1, again, I'll box it. -5x minus y equals 12. I'm going to solve for y here. So we're going to solve for y because it's the easiest. So I'm going to add 5x, so that cancels. So I'm left with a -y is equal to 5x plus 12. And then I need to divide by that -1 everything, which just changes everybody's sign. So y equals -5x minus 12. So there's step 1, I solve for y. Remember, these are equivalent, they're the same thing. That's why we've had to do this in the past. Okay, so that was step 1. Step 2 says, hey, once you have solved one of the equations for one variable, take that answer and plug it in. So we're going to take the -5x minus 12. That is supposed to equal y, so guess what we're doing? We're plugging it in for y in my second equation that I haven't touched yet. So if I rewrite 3x minus 5 times, now for the y, we're going to use what y equals, which is negative 5x minus 12, and that equals 4. So what I need to do is go ahead and distribute. I am distributing, remember, a negative 5 because there's a minus in front of it. So I will rewrite my 3x. Negative 5 times a negative 5x gives me a positive 25x. And a negative 5 times a negative 12 is going to give me a positive 60, and that is going to equal 4. Now I need to combine my like terms. So I have 3x and 25x, which gives me 28x plus 60 is equal to 4. And I'm going to then subtract 60 on both sides. So I end up with 28x is equal to a negative 56. And then I'm going to divide by 28 on both sides. And x is equal to a negative 2. So up. Ooh, kind of ran out of space. No, I'll write it underneath. My solution is going to be negative 2, comma, something, which is my y. Again, I have to figure out what my y is. So, let's myself some space. Step 3, I need to find what is y. Well, we already manipulated the very first equation into y equals something. I already know my x, so y equals negative 5 times x minus 12. Well, if I know x is negative 2, I can just plug that in. So y equals negative 5x minus 12. Y equals negative 5, and instead of rewriting x, I'm going to write the value of it, which is negative 2 minus 12. So y equals negative 5 times negative 2 is 10 minus 12. So y equals a negative 2. So my solution here is negative 2, comma, negative 2. All right, let's take a look at example 4. Please, again, make sure all this is in your notes. I know it's lengthy. But it's important. All right, let's take a look here. What do you notice? Well, hopefully you notice that these equations kind of look similar, but then they kind of don't. And actually, I'm going to change that negative 4. Bear with me here. Let's change that negative 4 to a negative 9. Okay? So here we go. We are going to do the same thing. Let's take a look. We need to solve equation 1 or equation 2. Neither of them have a coefficient of 1 for x or y. So we have to just choose one. So we've been doing everything in equation 1. Let's tackle equation 2. What do you want to solve for? I say let's solve for y. Okay? So if we solve for y, here's step 1. Step 1, I have 2x minus 3y equals negative 9. I'm solving for y. So I need to subtract 2x, So I am left with a negative 3y is equal to negative 2x minus 9. And I need to divide by a negative 3, divide everything by a negative 3. And I'm left with y is equal to 2/3 x plus 3. Okay? So now, that was equation 2 that I just messed with. So now I know what y equals. I'm going to take this 2/3 x plus 3 and plug it in for y in equation number 1. So here we go. Step 2. I'm taking equation number 1, which is 2x minus 3, and instead of rewriting y, I'm now going to plug in what I just solved, 2/3 x plus 3, and that equals 6. Once again, I have all x's. I'm going to go ahead and distribute. So a negative 3 times a 2/3, make sure you're distributing that negative 3 is going to give me a negative 2. So I have 2x minus 2x plus a negative 3 times a positive 3 gives me negative 9, and that equals 6. So once again, I'm going to go ahead and continue to solve. And so when I solve here, if you notice, my 2x minus 2x, well, that goes to 0, doesn't it? So I don't have any x's left. What am I left with? A negative 9 equals 6. Well, what's a negative 9 equals 6? Is that a true or a false statement? And hopefully you're saying, well, that's false from everything we've talked about before. That's false. So if it's false, guess what? Our solution is there is no solution. And if you notice from your previous slides here, with the graphing, those are the same examples that I used for parallel lines. So there is no solution. So if all of a sudden you're like, whoa, my variables are dropping out, they go to 0, and I want the false solution, that means that you have no solution. All right, so that's one of the special cases. 2 more, I promise, and then we are done. So let's take a look at these 2 more. All right, so if you look at equation 1 and equation 2, oh, look, the S equation 2 is already written as y equals something. So I don't even have to manipulate that anymore. So what I need to do is I need to take this 2x minus 4 and plug it in for that y. So I'm already skipping to step 2. Step 2 says take 4x minus 2 times it by what y actually is, which is 2x minus 4, and put that equal again to 8. So now I have 4x minus 4x, and then I have negative 2 times negative 4, which is plus 8, equals 8. Well, look what happens. 4x minus 4x is 0 again, and I'm left with 8 equals 8. True or false? Well, that's true. So if it's a true statement, that means, again, I have infinitely many solutions. I can plug anything in for x or y, and it will give me a solution, okay? So there's infinitely many solutions here. They're the same line. All right, let's take a look at example 6. Example 6, can you go ahead and pause and try it? Figure out what equation you want to solve for. Again, it doesn't matter at all. So go ahead and pause and try. All right, so I'm going to take step 1 here. I'm going to solve, let's say, x for equation number 2. So I have x plus 2y equals negative 6. And if I subtract 2y on both sides, I end up with x is equal to a negative 2y minus 6. If you solve for a different variable, no fears. Our work will look different now, but the answer is going to be identical. So now step 2, I'm going to go ahead and plug in negative 2y minus 6 for x in equation 1, because I already manipulated equation 2. So now instead of just writing x, I'm going to write negative 2y minus 6. And that's all minus the y is equal to 3. This is actually pretty easy. Negative 2y and a negative 1y gives me negative 3y. Don't forget that minus 6 is now equal to 3. Add 6, negative 3y is equal to 9. Divide by a negative 3, divide by a negative 3. Y is equal to a negative 3. So in my solution, I have negative 3 as my y value. Now, step 3, once again, step 3 states, hey, take that y value and plug it on into the equation that you just solved for to find your x. So that negative 3 is going to go right here into that equation. So x equals negative 2y minus 6.
All students ready next.
So x equals negative 2 times y, which is negative 3, and then subtract 6. So x is equal to negative 2 times negative 3, which is 6 minus 6. Oh my goodness, x is equal to 0. So my solution is 0, negative 3. All right, I know we went over tons of examples, but they are all very, very important. Here's your exit slip, just to do the very best you can, and we will check it tomorrow.